Quality Control and Improvement, Module 6, Lecture 2, Control Charts for Attributes. Learning objectives for Lecture 2 are to design attribute control charts to analyze a business or manufacturing product, analyze an attribute control chart to affect when a process is in control. So this is the second part of the lecture on attributes control charts, and in this lecture we're going to look at the C chart and the U chart. So first let's start with the C chart. What is it? It's used to monitor the number of defectors per unit. I think that's what the difference is. Examples, for example, the number of returned meals in a restaurant, the number of trucks that exceed their weight limit in a month, the number of discolorations on a square foot of carpet. All these would be examples of where the C chart would be useful to apply. So the average number of defects is the center line of the chart, and the upper control limit and lower control limit are given by the following formulas. So let's take a look at an example. I think this is the easiest way to understand how these charts work. So here we have a situation where we have the number of weekly customer complaints are monitored at a large hotel using a C chart. Complaints have been recorded over the last 20 weeks. We want to construct a control chart from the data. So here these charts are very simple to construct. I think that's why a lot of people tend to try to use these. So here we list the number of weeks, and each week we just tally up how many complaints there are during that week. So for the 20-week period, we had a total of 44 complaints. So the average number of complaints per week is simply 44 divided by the 20-week period, or 2.2. Therefore, the C bar, the complaint average, sort as 2.2. From there, we can compute our upper control limit and lower control limit using the formula. Upper control limit, we get 6.65. The lower control limit, we get 0, or we get less than 0, so we set that to 0. We can't have a negative control limit. So once we enter this data into Minitab, again, this is a single column. Go to Stack Control Charts, Attributes Charts, and select C. Minitab will then automatically generate the control chart. Here you can see the limits here. Just check these are the same limits we had by doing it by hand. So everything looks fine here. So these are very easy charts to construct. Minitab does a beautiful job of it. So let's take a look at another example out of our textbook. Here we have an automobile manufacturer samples 100 tires from the production line, develop a C chart for the data. So here, reading this chart, you kind of have to, you actually have 26 samples. So samples 1 through 13 are in the first two columns, and samples 14 to 26 are in the third and the fourth column. So here, sample number 1 that we selected 1 hour, we pulled off 21 tires. We found 21 nonconformities. Out of the 100 tires we selected. So each sample number, we're pulling off 100 tires. In the first hour we found 21 of them that were bad. In the second hour we found 24 of them that were bad, etc. So once the 26 samples contain 516 total nonconformities, again we just added up the number of nonconformities. We can estimate this by taking 516 divided by 26, so 19.885. And then again, we calculate the control limits exactly the same way we did in the previous example, except here the lower control limit is greater than 0, so we just leave it as what we found there. So again here, Minitab is used to plot the results. Except in this case, as the book points out, notice you have on the initial chart here, you have 2 of them that are out of control. Points 6 and 20 here fall outside of the upper control limit or lower control limit. So those are problems we have to investigate to see if we can find an assignable cause. So in this case, we go out and we find that there was an inspection error. Here the inspector just made an error. We rechecked that tire and it's okay. There's no defect. And also up here, maybe we had a problem with a temperature controller, so we actually know what caused this bad sample. So so therefore these two samples can be excluded from our data set, and then we can just replot because we found assignable errors. That we know what caused these problems. So it wasn't the problem with the process; it was a problem with just a failed instrument or an operator error kind of thing. It's not a problem with the underlying process that we have. So again, here, once we find that we have these problems, then we take those particular samples out of the data, and we replot the C bar. So instead of having 26 here, we have 24 now, and then we just basically cross off that data, and then we have to recompute our control limits. And that way we can use these as a new setup for a control chart to evaluate stuff going forward. So once we set our new upper and lower control limits, we can start collecting new data again. So here let's say we collect more data the following day, samples 27 through 46. We can plot those right on the same control chart. So here we plot 27 gets plotted here, 16. 28 gets plotted up here to 18, etc. We plot the new data on that revised control chart. And here, again, we can analyze the control chart here. I mean, this looks kind of odd here, right? You have a kind of going downward, so you kind of have to be careful with that. It looks like we have a downward kind of trend there. It does bounce up above 20 here, so that's good. But it's just kind of something to keep an eye on as we go forward to monitor. Obviously, we didn't exceed the upper control limit or lower control limit, but we might want to monitor for any general trends to see if we have potential problems developing. So last case, let's take a look at the U chart. This is very similar to the C chart. However, like the C chart, the U charts can be used with variable sample sizes. And here the upper control limit and lower control limits are given by the following formulas. And let's take a look at an example to see how to apply these. So here we have a supply chain group monitors shipments of materials through the company's distribution networks. Errors on either the delivered material or the accompanying documentation are tracked on a weekly basis. Each week, 50 randomly selected shipments are examined and the errors recorded. We want to set up a U control chart to monitor this process. So here this shows the process for 20 weeks we do this. The sample size is 50, and out of every week that we draw the 50 sample sizes, we just count the number that are errors. So 2 divided by 50, that's where we get the average number of errors per unit. 2 divided by 50 is 0.04. We do this the next week, we get 3 divided by 50, 0.06. So every week we calculate these. So the total number of errors, we simply add up the third column, we get 74. The average number of errors per unit, we add up all of these guys, we get 1.48. So here we can estimate the number of errors or nonconformities per unit to be, so here U bar is the sum from I is 1 to 20, so we had 20 sample weeks. Use of I, so that's this column here that we've calculated here, the 1.48 divided by the number of sample numbers, which is 20. We did this for 20 weeks, 0.0740. The upper control limits and lower control limits are calculated using the formula. So it's U plus 3 times the square root of U divided by 50, because 50 is the sample size in. The lower control limit turns out to be negative, so we set that to 0. So here, you can use Minitab to plot this again. We're not going to plot these by hand on a piece of graph paper. Minitab does a much more professional job of doing that than we could. So here, if you look at this this plot, they do not exhibit lack of statistical control, and then we would probably use this, and based on that, we would use this for phase 2 of our monitoring for our future operations. There's one thing that to note here, though, that although again the process is theoretically in control, there's a lot of these are pretty high peaks here, coming up here. So the average number of errors here per shipment is kind of high. You probably should, based on this chart, I would begin looking for potential signs of errors, or try to track what's going on to try to improve our process, because this could easily drift up and be above the upper control limit. That's a little bit concerning, that there's such a wide variation here. It'd be a lot better process if you could kind of if you saw these peaks be not so high and the lows not be so low. So this looks like you have plenty of room for improvement in your supply chain.